Do you need this?
Okay, can we make a start? And again, someone who I've known for quite a while and have worked with, and I'm very pleased that he was able to be here. Stuart Trow, who has done a lot of work looking at just where the losses are and whether they're actually losses. And so I think people might find some of his results quite interesting.
Thank you, Joe. Thank you, everyone, for staying so late. We've lost a few people, including the regulator and 3 of the water companies, but it would have been good if they'd listened to what I say. But maybe if you're dealing with the water companies, you can pass on some of the messages I'm going to give this afternoon. Talking about customer side leakage. So we've talked about trunk mains and then distribution mains. So we're now down at the sharp end of the system where the customers live. When I saw the programme, there's also this strap line, so in estimating customer side leakage, plumbing losses and supply pipe leakage. Yeah, I'm going to cover that. I didn't realise I was covering it until I saw the agenda, but that's fine, we can cover that. So, start with a bit of background and some definitions, and then talk a little bit about Invenio systems and what we've been doing, and then what we found, some of the results that we found. So terminology, this is a house. We have the boundary of the house, we have what's the water mains here, we have what's called the communication pipe, which runs up the stop tap. The water main and the communication pipe are owned by the water company. The supply pipe is owned by the householder. We have distribution losses are on the water main and the communication pipe, and then beyond the stop or beyond the boundary is what we call water delivered. And water delivered includes consumption within the property and underground supply pipe leakage. In the UK, which is a bit different from some of the other percentage figures you saw from other parts of Europe, we report total leakage. So although the water company isn't responsible for the supply pipe, we still report the level of leakage on that supply pipe. So when you're comparing 23% leakage in the UK with other parts of Europe, bear in mind other parts of Europe are only reporting leakage on their network and not on the customer's network, which seems sensible to me, but this is what we do in the UK. Consumption includes usage within the properties and plumbing losses. And I want to talk quite a bit about plumbing losses. So we have the point of delivery and the point of consumption. These are water meters, so we can either put the water meter inside the house, in which case we just pick up the consumption, or we can put the water meter at the boundary, in which case we get the consumption and we get the leakage on the supply pipe. And you know, there are different trains of thought as to where you should put the meter. But of course in the UK, only about 50% of properties on average are metered. In the southeast it might be about 85% of properties. It's never 100%. Very rarely is it 100% in any area. Probably the best you can get is about 85%. In Scotland, out of 2.2 million properties, only about 700 are metered. So that's the other extreme. In the north of England, it's maybe about 35–40%. The other bit of terminology is what we call the different types of leakage that we have. So I have this iceberg diagram some of you may have seen. At the top we have what we call reported leakage. Has anyone heard of BABE methodology? BABE, you've heard of BABE. Not many people have heard of BABE. Okay. BABE has been around for 25 years. It stands for Burst and Background Estimates. So bursts, we have spectacular vents reported bursts where it's obvious there's a leak. You don't need to go and look for it. That accounts for about 10% of our reported leakage because although the big events, they don't last for very long. Then we have the unreported leakage below the surface, which we find with the find and fix activity, the active leakage control. That accounts for about 30% of our leakage. And then we have, on the deep dive, what we call background leakage. And that background leakage is really an act of faith. It's what you're left with out of total leakage after you've accounted for how much is due to this and this. This is what you're left with. And about 5 or 6 years ago, myself and my colleague in Invenio Systems, a guy called Steve Toombs, we started questioning this thing called background leakage to say, what is it? Where is it? What can we do about it? Because if we're under pressure to half leakage, and 60% of it is something that we can't see and we don't know what it is, then clearly we've got a problem. So if we go back to UK Managing Leakage Reports, 2011, I've just realised 3 of the people that wrote those reports are in this room, Joe, myself, and Malcolm. Dave Pearson's the missing person, but the 4 of us updated Managing Leakage, which was produced in 1994 and updated in 2011. And in Managing Leakage, there's a table of background leakage components. And if we look at the average condition, we've got 40 litres per kilometre on distribution mains, 3 litres per connection per hour on communication pipes, 0.5 litres per property per hour on supply pipes, and 0.5 litres per property per hour on plumbing, internal plumbing. Of course, this 0.5 is part of leakage, and this 0.5 is part of consumption, so it's not leakage. So actually, one of the first things myself and Steve Toombs did was to see where did these figures come from. We found that they were based on a very limited sample, and the 1 litre per property per hour going past the boundary stop tap, someone went, let's just assume half of that is internal and half of it is external. And since 1994, that half has been part of consumption and the other half on the supply pipe has been part of leakage. So we thought it was about time we looked into this to see where the water was really going. Also down here, we've made a note that any of you who know about ILI and unavoidable annual real losses and so on, 65% of the ILI is background leakage. So it is significant. And if you look at a typical urban area with a mains length per property of 10 metres, only 9% of that background leakage is on the distribution mains. 68% is on the com pipe, 11.5% is on the supply pipe, and 11.5% is internal plumbing losses. But you see the significance of the service connection in terms of background leakage. So, very simple diagram, which I think sort of leakage experts might not appreciate this, but hopefully the rest of you will. The amount of leakage that we have in the network is made up of these 3 components. How many leaks we have, which is governed by the infrastructure condition and to some extent the pressure in the network. The leak flow rate, which is clearly the size of the leaks and the pressure in the system. And then the run time. And the run time is really significant. That's the main thing that we can affect when we do active leakage control, find and fix activity. And this again is from managing leakage. So a reported mains burst might be 75 cubic metres per day, but it only runs for just over a day, so it only loses 82 cubic metres of water. A service connection burst, 25 cubic metres a day. ALR is awareness, location and repair. So it's the time between the burst occurring, or the leak occurring, and it being fixed. Might be 16 days because it's reported. Someone's aware that there's a leak there and water company comes out, finds it and it's fixed. 400 cubic metres. An unreported service connection burst, so this is when you don't know it's there and you have to wait until the water company comes into that area and goes around looking for it. Again, is running at 25 cubic metres a day, but it might be 6 months before you're aware that there's a leak there. So it loses 4,500 cubic metres. So again, you see the significance. You've got a lot of leakage, background leakage on the service connection, and you've got a lot of burst leakage on the connection as well. But what we've also found is we found a lot of small plumbing leaks, which might only lose a cubic metre a day. Okay? Small leaks, either from the plumbing system or on the service pipe. And they might run all year because you're just not aware that they're there. And again, simple calculation, 1 cubic metre a day for a year is 365 cubic metres. So it's about the same as a reported service pipe burst. But what we're finding with the surveys that we're doing is there's an awful lot of them, and we're not looking for them. So this thing which we call background leakage, there's a good chance that a lot of it is this. Managing leakage, by the way, defined it as being small leaks below the detectable limit. And technology's come on an awful long way in the last 25 years, but we still report the same level of background leakage. So maybe It's because we're not looking in the right place. So then, how do we calculate customer side leakage? We've got what we call a top-down method and a bottom-up method. Top-down, we look at how much water goes into the network, we take off the consumption, and what we're left with is leakage. Bottom-up leakage, we look at night flows in DMAs, and again, we estimate how much of the night flow is consumption, how much of it is leakage, and then we add it up. And then we reconcile the two. But we then need to split that into, once we've got total leakage, how much of that leakage is on the network, how much is underground supply pipe. We need to confirm how much is plumbing loss, and we also need to check the night use estimates and the per capita consumption estimates as well, because that's part of the equation. That's something that Ian Pemberton touched on this morning. We need to get a better handle on whether it's leakage in the first place. We then have this BABE estimation for customer side leakage to try and work out how much of our total leakage is on the service connection. And the way we tend to do it is we take how much is background leakage from the figures I've shown. We then say how many bursts have we found, how many leaks have we found on service pipes, how long do we think they've run for, and what do we think the flow rate is. We take account of things like leakage rebates on metered properties. So if a metered supply has a large bill, the customer's given a rebate. But it's a sort of self-fulfilling prophecy. If you're not looking for the leaks and not finding them, then it doesn't go into this calculation. So there's a tendency to underestimate how much of the leakage is on the customer side because you're not finding and fixing the customer side leaks. CIWEM, Chartered Institute of Water and Environmental Management, have a PPS, a policy position statement. That was updated quite recently, and it suggested that 25% of total leakage was on the underground supply pipe. But it does vary quite a bit between one company and another, and it varies depending on the degree of meter penetration from one company to another. So that's a bit of background. Talk about Invenio systems. Why did we get into this? We got into this because of the picture I've just shown. Background leakage. Is it what we think it is? Are we looking in the right place? And we did, back end of 2014, so 5 years ago, we did a club contract for 6 water companies looking at how they calculate per capita consumption and night use. And we found that they were leaving out, the general principle was to leave out any high values because, well, there must be something wrong with that figure. It couldn't possibly be as high as that. And then take an average of the rest. And we thought, well, maybe those high values are correct and they should be included in consumption and night use. So we started to think, well, what could we do differently? And we've heard a lot today about flows and pressures and acoustics. And someone this morning said, that's how you find leakage. We thought, well, it's no point in doing the same again. We did a bit of a brainstorm and we thought, could we do something with temperature measurements? So Joe this morning talked about like world firsts in the UK. What we've done with Invenio is pioneer the use of temperature measurements in the water distribution system. And we find not just leaks, but also consumption events as well. So the principle is that as the water flows through the network, the temperature changes. And we can model the temperature. We can produce thermal models of the network, and we can compare actual temperature against model temperature. For customer supplies, if there's no water going through the stop tap, then the stop tap sits at the ground temperature. If water is going through the stop tap, then it tends towards the temperature of the water in the water main. And it's very complicated. We're still developing the algorithms and the machine learning approach to get it exactly right, but it's come a long way since the early part of 2015. 2016, we did full surveys of 6 DMAs where we fitted what we call our stopwatch logger onto every stop tap in a DMA, and we had some very interesting results from that. 2017, we started a major program of work with Welsh Water and other companies. Last year, we developed another sort of what I would call non-acoustic technique, not temperature, but vibration. And what we were doing there was sensing, is the water going through the stop tap or not? And then 2019, we've got a framework with Thames Water, and we were acquired by Halma. And we now bolt onto HWMs. And the reason that HWM are interested is because they produce acoustic loggers. Just for the reasons that Stuart Hamilton said, acoustic loggers don't work well in plastic pipe systems, but because we've got non-acoustic systems, we can then cover the whole of a DMA, and we can do rural areas with long lengths of mains. So we've now got 3 offices, 20 staff, 9 vans. We've got a cleaning truck, like a Ford Ranger truck that cleans out the stop tap pits for reasons I'll come on to. And we've got 3,700 of these devices. And we're now working outside the UK as well, in Italy, Ireland, Australia. So these are the sort of 3 techniques we have. We've got our stopwatch logger that we fit to every stop tap in an area, or we do random sample surveys of properties. We've got our stop check device, which is the sort of vibration sensor to see is the water going through the stop tap or not. And then this is something which we've just developed in the last 4 months with Halma. This is a communicating stopwatch logger, which we call Flow Watch, and this is moving upstream, putting sensors inside the distribution system to subdivide DMAs into smaller areas. So if the DMA flow goes up, so we heard the presentation from Servlex saying, you know, there's a leak in this area. This helps identify whereabouts in that area the water's going. And because it's non-acoustic, it'll work on any type of pipe. So how do we separate plumbing loss and underground supply pipe losses? Well, we tend to do a stopwatch survey. We put the stopwatch loggers onto properties, either full area or random sample. From that, we generate points of interest where we think there might be a leak. We estimate what the flow rate is, but at that point, of course, we don't know whether that's internal or external. We just know there's a continuous flow of water past the stop tap. So we then have to make an appointment with the customer. In some cases, we'll fit a water meter. Just by the by, there's cases where we fitted a water meter and the water meter hasn't turned. So the water company said there's no leak there. We've then visited the property and found, yes, there is a leak, but it's not turning the water meter. So that's another issue. We've also had cases where we said there's a leak, and the water company sends a technician who listens on the stop tap, and he said, no, there's nothing there. Don't know why, which is for the reasons that Stuart was talking about. Once we've got into the property and we see what it is, we then estimate how much of the flow is due to an internal leak, part of consumption, and how much is due to an external supply pipe leak. But that's the only way you can split it, is by actually visiting individual properties. Trying to estimate it, it's so variable, is very difficult. So you need to go and visit the property. So who have we done this for? We've done part of the leakage consistency methodology, which came out a couple of years ago, says that each water company should have its own specific estimate of plumbing loss, which is great news for us because it's generated work. We're the only people who really can do that. So we've done this for 6 water companies. We've also done a study for Uckwea as part of the zero leakage program that Joe mentioned. And we did that across 5,000 properties across 4 companies. What did we find? Well, taking the whole sample, I've just looked at good quality data just really for this presentation. A sample of 11,810 households across 8 companies. Just about 10%, 9.9%, had some sort of leak indicated from the survey. Now think about that. That means in a DMA of 1,000 properties, 100 of those properties indicate some sort of leak. Okay? And this is where we've got good quality data from our system. When the water companies try to make appointments, about half of them haven't been followed up because the customer wouldn't engage, which is another issue. Of the ones where they did engage, so we've got, there's a rough split between 2% of properties there was a confirmed plumbing loss, another 2% there was some sort of leak, but not really confirmed, and then only 0.4% had a confirmed supply pipe leak. We think actually some of these properties probably also were supply pipe leaks as well. It's still significant though. If you had 1% of properties in a DMA, it's still 10 service pipe leaks in that DMA. The success rate varied considerably. So these are different companies, different surveys. So you've got one company here where they only followed up about 7 or 8% of properties, but where they did follow it up, 85% of them had a confirmed leak. Then you've got the other extreme where this company followed up 90% of POIs, what we call property points of interest, POIs, and had a 30% success rate for whatever reason. I think it depends how they follow them up. On average though, 50% of properties were followed up and 50% of those had a confirmed leak. What were the types of leaks? The supply pipe leaks were mostly leaks under 100 litres an hour. The ones over 100 litres an hour we tended to find by other methods. These areas generally had been swept for active leakage control to find the leaks before we went in. We had one example in Wales where they did an intensive leak detection survey, found 10 customer side leaks. We went in and found another 30 customer side leaks. On average though, the managing leakage plumbing loss figure, as I said earlier, was 0.5. We found the average was 1.3 litres per property per hour over the areas, over these 11,000 properties. These were toilet leaks, and particularly newer types of toilet with flush valves, just the water running constantly down the back of the toilet, running taps, overflowing roof systems, leaks on central heating systems, and leaks actually that the householder didn't know because they were under floors and behind walls. What does that mean for leakage? Well, if plumbing loss is 1.3 and not 0.5, that's 19 litres per property per day, which is 20% of leakage. Average leakage in the UK is about 95 litres per property per day. It varies considerably from 63 to 125, but on average, that's 20% of the leakage is plumbing loss, the true level of plumbing loss, not what we thought it was just 7 or 8 years ago. But the night use, we also found that night use is higher in what are called high leakage DMAs. So as well as looking at the leakage, when we go into to do a survey of a full area, so this is an area in Wales called Picton Pennyford, 350 properties. The night flow on the district meter is 5.1. So that's the orange line, is the average from the district meter, 5.1 litres per property per hour. The night use events were 2.1, which is about average. But there were continuous flows, customer side leaks, which added 2.4. So actually the network leakage in here was only 0.6 litres per property per hour, whereas the water company would have been reporting maybe about 2 litres per property per hour. Here's an extreme example. This is a DMA in, I can say which company it is. It's Anglian Water, Peterborough. It's near Peterborough railway station, 2,000 properties, tourist housing. The night flow in the area was 13.7 litres per property per hour. So they were reporting high leakage in that DMA. We did a full stopwatch survey. We found the customer use was 7.8, just the use. So that was about 4 times the average for the company, just the use. When we added the 100 customer side leaks that we found in that area, suddenly we've got no leakage on the mains and com pipes. So trying to achieve zero leakage, well, here's a DMA that does have zero leakage. They're not reporting, or they weren't reporting zero leakage. They were reporting something of the order of 10 litres per property per hour. But actually, there was no leakage on their network. And that's typical of what we found in other places. So here's a sample of 25 consumption monitor areas that we've done, 6,500 properties. Here's the night flow, 5.1, say, 2.2 of night use, 0.5 of plumbing losses, so 0.5 of customer side leakage, so 3.2 of water delivered. They were estimating network leakage of 1.86 litres per property per hour. In fact, network leakage was only 0.9, and the total water delivered was 4.16. So whereas in these areas, the water companies thought it was 19% of total leakage, it was actually 34% of total leakage. And these are well-managed areas that they use to estimate per capita consumption and night use. If we look at some other examples of these high leakage DMAs, the average was 11 litres per property per hour. So the water company would again have said 2.2 of use, 0.5 of plumbing losses, customer side leakage, estimated being 25% of the total, and network leakage of 6.25. In fact, we found the night use was 5.2, so 2.5 times the average. Customer side leakage, 1.91, in addition to the plumbing loss. So in these areas, customer side leakage was 40% of the total leakage. just gives you some examples of what we find. We find time and time again that these high leakage areas it's not leakage on the water company's assets, it's leakage on the customer side. And again, using this stop check device I've mentioned, we've done what we call stopwatch light surveys, 15 DMAs, about 15,000 properties. And I've looked at a sample of 10,000 of those properties. 10 to 15% have some sort of leak, and 3 to 7% have significant leaks. I put this together yesterday, and then Stuart sort of stole my thunder. But it just emphasises why we're not picking up these customer side leaks, right? This is what has to happen. You start that the leak has to make a noise. Well, maybe 90% of these customer side leaks make a noise. The noise then has to travel to the stop tap. The stop tap has to be accessible. Well, don't get me started on that. When we've gone around doing these surveys, we've found a shortage of stop taps. We found that the covers are seized up. When you do get the cover up, you find that it's full of debris, for want of a better expression. We found nappies in stop tap chambers. We even found a car radio in a stop tap chamber in Scotland. So the inspectors who are doing the leakage control just walk past those and go to the next one. They don't do them. Then the noise has to travel up the listening stick. We found with a stop check device, if we put the sensors on the stop tap, we get a reading. If we put it at the end of a listening stick, we don't get a reading. So the leak noise is not enough, doesn't have sufficient energy to travel up the listening stick. Then even if it does, this is what Stuart was saying earlier, the leakage tech has to say, yeah, that's a leak. So what we're finding is, I mean, this is a guess. You know, we might only be picking up 20% of the leaks on the customer side in the area because of all these reasons. So, key messages. The night use in many areas is higher than we assume. The daily consumption is also higher. The internal plumbing loss is definitely more than previously reported. The night consumption varies considerably between areas. So if you take an area and you say, this is the night flow, we're going to take off this for customer use and the rest is leakage, then you're kidding yourselves, right? That's the disadvantage of having DMAs. It can actually fool you into what you think is leakage and what you think is customer use. But definitely some of what is being reported as leakage is not leakage. And then if it is leakage, there's a lot more happening on the customer side, so the network leakage is lower. So they're my two key messages summing up the presentation. Leakage is probably lower than what we're reporting, and there's more of it on the customer side.
Thank you very much.
Okay.
Maybe if we just have time for one question, but if I can just make one comment. What a wonderful Trenchless sort of demonstration of how to reduce leakage.
Yeah.
At one fell swoop.
You're right. We're picking up these points of interest and we're saying there's a leak on the customer side, and the water company is then struggling to understand what to do about that. You know, things like Aqua-P have been tried with some success in certain places, but not universal success. But certainly there's definitely a market there for a good system to tackle customer side leakage.
So one question, possibly. Oh, okay.
Yeah.
Thanks, Stuart. One thing I was wondering is, you quoted some average results there. I was wondering how different, or whether you can see this in your results, how different they were between properties that are measured externally at the boundary versus those that are unmeasured or measured internally. In that, how much of this would actually be picked up by a meter or not? Right.
Good question, and it's one that I think we can answer. We've been asked that question for a long time. I think we can answer it now. The bigger leaks are picked up by the meter. They're also picked up by the routine active leakage control. The smaller leaks are not picked up by either. So we're finding, this study we've done for UKWI on plumbing losses, we're finding that the level of plumbing loss in metered properties is probably as high as it is in unmetered properties. And one of the reasons for that is if you have a meter, unless it's a big leak, it's very difficult to tell whether the consumption on that property is due to a leak or whether it's due to the fact there's 3 people live there or 2 people live there. And even if you go to smart metering, which I have my doubts about smart metering because you're still relying on the accuracy of the meter, but you only get readings every hour. So again, do you drill down far enough to say that's a leak, or whether it's just, you know, the tail of a toilet flush or the washing machine running or whatever?
It's a yes, no answer, Joe.
Yes, I could see you were dying to say something.
Stuart,
so.
tell us if you have, yes, no, calibrated your temperature measurement against a water meter.
Yes. But it's not as easy as putting it on a test rig, because our system won't work on a test rig. Our system works on the difference between the stop tap temperature changing, so it has to be in the ground. But we've built our own underground test rig, and we've tested it with an accurate an EM meter.
And can I just say that there has been a swap from your programme. Steve will be presenting at the end, but please don't go away until you hear him, because that's has some relevance to this, I think. So, you know, stay to the bitter end if you possibly can, because it will be interesting. So now, thank you very
Thanks.
much again, Stuart. So
Who's next?
very interesting points there. And I'd like to introduce Christian Dobritzberger. I hope I again pronounced that right. And we've done a swap
Cheers, bud.
because Christian has to leave rather promptly. So
On time.
I know he's very strict on time.
Yes. Good afternoon, or rather good evening, everyone. My today's paper is about the world's first trenchless solutions for connecting a service house to a water main in entirely trenchless way. But before, a brief introduction about the Havle Austria Group, which I work for since 2016. We are basically a premium manufacturer of valves and combis, butterfly valves, house connection stuff, hydrants, pipe connections and fittings, multi-range couplings, network control and protection valves, and various accessories. It was founded in 1948, so we had our 17th anniversary last year, quite a big party. It's 100% family-owned business, so in total we have about 1,200 employees, which are working in 9 factories in Europe. We also have run our own foundry. We have 14 subsidiaries and distributors in over 70 countries, and we have an exceptional high in-house production depth. So that means we produce almost everything ourselves, so we don't rely much on external suppliers because we have very high demands for quality. And extraordinary durability. Just last week I visited a customer in Austria in a pumping station. There are valves there which were installed in 1967 and they still work very, very well. So durability has a very great importance for our company. In total we have about 10,000 different products in 30,000 variants. We give a mandatory 10 years guarantee for all our water products. So 95% of our products are for water supply. A few products we have for gas as well as for wastewater. We generate an external turnover of about 150 million pounds. Then I would say we are governed by a pioneering spirit. For example, the nowadays known resilient seated gate valves, for example, is an invention of Havle. There was a patent in 1958 filed by Havle, which was the first resilient seated gate valve, for instance. And from our revenues, we spend about 10 million pounds for reinvestments or for innovations. And in 2014, 2015, it was decided that we could do an innovation for our house connection portfolio. And it coincided with an initiative from the Oslo Waterworks in the capital of Norway. So they have launched an initiative to boost the pipe bursting, to do more pipe bursting in their city, to enlarge their pipes to increase the capacity of the pipes. But what they found is they apply this quite marvelous technique, but in the end, the services need to be connected, say every 10, 15 meters there is a service. So, and it looked like then, okay, every 10, 15 meters there is a pit for connecting the services. So we were still in business because we manufacture these kind of saddles, shut-off saddles for hot tapping, but we thought we could do better. So they launched a public tender. It's a so-called pre-commercial public tender in 2014, the so-called Nordic Challenge. We participated. Then there were about 40 different companies really interested in getting into this challenge. But in the end, only we survived and won this challenge in 2017, yes. The primary aim was to establish service connections after pipe bursting without any digging, and also to reduce the water losses and with no impact to the traffic or public life. And Oslo believed that 70% of their leakages occur here or in the service itself. So, okay, I will jump over this slide because I have to observe time. So we won this challenge, as I mentioned. We also got the last year's ISTT award for new machines. And we were also finalists of the Norwegian Tech Award, where we had to compete with aviation stuff and military stuff and so on. So we finished the 4th place. But what did we for these awards? This is a very simple demonstration, if it works. Yes? So a well-established area, nice pavement, a water main. Say it was replaced already with pipe bursting. So nobody wants to have a lot of pits here so that the road would look like a Swiss cheese. So the very important initial step is to know the location of this pipe very precisely, because in the end we have to hit it. To cater for this, we have developed a pipe locker which is run through the pipe a couple of times. It has like a lot of sensors, acceleration sensors, gyroscopes and so on. When we know this location, then we do a drill through the basement's wall. This is like a kind of checking frame or like a wall seal. Then, I mean, this is all a little bit simplified, as you might see later. Then we drill in a steered manner. We can go around obstacles to some extent, hit the main pipe, and then connect. And when everything went well, there is no excavation here. And we open the tap and get fresh drinking water. Well, that looks like quite simple, but the truth is, it is not. As mentioned, there are a lot of steps involved. The first step is the pipe locker, as I mentioned already, with a lot of acceleration sensors and gyroscopes inside. This is how the prototype looks like. So we achieved quite good accuracies with, say, 2-3 centimeters. It can still be improved, but we are satisfied with what we had. We have tested it on a test site of the Oslo municipality. They have given us an abandoned pumping station, which was our playground where we could try out all our stuff. So we have run these lockers a couple of times here through and found the results quite satisfactory. Then we have to drill here through the basement, fix this bracket here. Here this is like a checking frame for my pipe checking equipment, but on a much smaller scale. Here you can make out that this is still a prototype because there is plenty of hoses, cables and stuff. so that in an industrialized version it has to look a bit more neat. This is an animated picture of the drill string. Then we have a steering software with a target, which is like very similar to how we know it from the microtunneling. Then this is like a section through the basement. This is the planned drill path here. These are the pipes which we saw before in the picture, which we have to hit, and this is how far the drill has advanced. It is a steerable drilling, so that means we have a very special steering joint, and which is very compact. It has to be very small because we don't have much space down there. And a drill head which was not easy to develop because it has to cater for so many different soils, so many different conditions. For example, it has to go through wood, for instance. You know, so they have the Oslo Waterworks. They have buried some wood there, and we're checking whether we can pass through or not. They put a lot of obstacles inside. And what I didn't mention is there was public funding involved as well, so it was under very strict monitoring, the whole thing, because we got public funds for it, so they were very strict on observing the progress. The drilling is like a little bit similar to the microtunneling process. So we also have a cone breaker, so this is the dismantled, the drill head is dismantled from here. This is a cone breaker where gravels can be ground and then conveyed in the drill string to the basement. We had to develop a very special hydraulic motor with a hollow shaft because that the spoil has to pass inside the drill string. It's a patented motor, by the way. Yeah, this is the wood I mentioned, which we had to pass through. Here, after we did a drill, we excavated the area, always to see how the skin friction and everything went. And here you can see the curvature which we did. So we achieved a curvature radius of about 20 meters, which is quite sufficient for our purpose. Oops. Can everyone hear? Well, we had also we had to use a forward flushing to avoid balling. So that means the drill head in clay soil would get totally jammed, and so just rotate and not excavating anything. There are backward jets here to force the material in, so it is conveyed inside. So in case there are obstacles found on the drill path, like larger boulders, for instance, we have developed a multi-tool which can drill a pilot hole into the main pipe, and which can also remove obstacles. Like, for example, it has an arm here where we can you?
Yeah.
Sorry. It has an arm here which can push an obstacle aside or displace maybe a larger stone or a boulder into the ground. It's about 2 tons of force which we can apply here. And after the drill is done with the protection sleeve to the main pipe, we drill a pilot hole, which makes it later on easier to detect the exact location from inside the main. So the next step of the process is, once we have provided a sleeve from the basement to the main, then we have to do the connection itself for the service pipe. And for this, we have developed a robot which is actually hosting a core drill as well as a special made fitting, which is later on used for the connection. So here you can see the drilling. That robot is inside the pipe, and it actually takes out that core for practical purposes and also for hygienic purposes. That core should not remain in the pipe, so it has to be taken out, and on the reverse operation, the core is taken within and later on taken out from the pipe. And when this hole is drilled, then the robot moves a little bit ahead and screws in, threads in that fitting. You can see it very slow rotation, how the threading is going on. So it requires quite high forces because in the end it should be all watertight and durable for a long time. So the last step is when the fitting is placed on the main pipe. Eventually, then we have to install the service pipe to get the water running to the building. And that works that this is the sleeve. This is the service pipe itself without the fitting yet here. So this is the fitting attached to it. And this is like a hydraulic worm which is inserted into this ordinary polyethylene pipe, and it can be bent. And there's a camera on it, and the operator in the basement can exactly position the female part of that fitting over the pipe, and then give it one push, and there is a snap fit which will last. Yes, done. Yeah, everyone was cheering. So the current range of application is, so far we have succeeded with PE pipes, PE 100 RC of DN, means outer diameter 180. It has an internal diameter of 147. So we haven't come any smaller yet, but we can go larger. And that is usually on pipes which have been laid by pipe bursting, HDD, perhaps slip lining or close fit lining. And the house connection pipe, the service pipe, current range of application is from 25 to 40 mil internal diameter. The sleeve pipe is 103 millimeters. By now, we can only work when the service pipe, when the main pipe is out of service, but that is typically the case when pipe bursting or HDD has been done. The maximum drilling lengths, which was a design criteria, was 30 meters. So far, we have succeeded in 24 meters. We didn't have any longer span available. The major challenges were like drilling a blind hole. So that means we have to drill from the basement to the pipe. Number one, we should hit it pretty much precisely. Number two, we have to retract the whole drilling equipment and should also not leave the borehole like unprotected. So that means the drill head, here you can see it has like collapsible blades so that we are able to pull it back in the sleeve pipe. The most challenging part, in my opinion, was the miniaturization. So to make everything small, you have to imagine it needs to be portable. You have to walk down in a narrow staircase, maybe into some house's basement. Should not be too heavy, should not be too big, but the soil to be excavated requires a lot of force. So the miniaturization was one of the greatest challenges. Then also the removal of spoil, the reliable removal of spoil. Nobody wants to have a spillage in his basement, so everything should be neat and clean afterwards. To have sufficient power, yeah, this is the robot inside a plexiglass pipe where you can see that everything has to be very small, but for example, to thread it in, we need up to 400 Newton meters. And that on such a small space, it requires special techniques. Then there was also a completely new approach for tapping was required. As you have seen, it's not a standard fitting that can be used, any standard material. And it's a fully remote controlled operation. So that means everything is done by robotics. So there's no hand that can be applied to support the process or anything. And in the end, this was also, the budget was a challenge. It has cost quite a lot so far. So we have hired an external R&D company in Norway. They have expended around 35,000 hours of man hours of like highly skilled R&D engineers, and we have paid for it. But what are the results and the benefits so far? It's the first solution of that kind worldwide. It is tested and approved by a renowned municipality, which is the Oslo Waterworks. It can be a quick and cost-effective solution. It is not yet, to be honest. You're not there yet. It is practically no impact to the social life, to traffic, to the environment, because everything is done fully trenchless. It can be a completely weather-independent operation. So specifically in colder countries, that's an issue. It can be the missing link towards fully trenchless. And when we close this missing link, that could give a big boost to other technologies, because then open cut excavation will not be that attractive anymore. So some customers may opt for more pipe bursting, more HDD, so it could be something that helps the whole industry. So we have applied for 6 patents, 4 are already granted. Due to time, I spare you from statistics, but there is an immense scope of work which could be there for this technique. And here, just a few future visions, how an industrialized equipment could look like. So we have pretty good design ideas. So that has been done by industrial designers on the real scale of the equipment. So operator friendly. So I jump over just a brief outlook. So the R&D works are largely completed. The technology readiness level is between 5 and 7. The installation has not yet industrialization has not yet commenced, but we have recently signed a collaboration agreement with a large German pipe robot manufacturer, with whom together we will complete this development. And we assume that we will be at site with our first industrialized equipment in 2 years' time. That was a very short advertisement about our distributor in the UK. The company's name is R2M. We heard a lot about leakages today, so they have really good solutions with off-the-shelf live encapsulation collars. So the advantage is they have a very wide tolerance range, and if you have any urgent leakage, they also have the installation service available. And that was it, and thanks for your attention.
Fair enough. Because I think it's important everyone has a chance to present this afternoon. But I think it's a case of you saw it first here. I'll be interested to talk to you before you go about how you cope with houses that don't have basements, which is the norm in this country. So the next presentation, is it a double act?
Just one.
Oh, okay. So we have one of the Simons talking about the Kobus pipe puller. And I remember talking to Kobus at a No Dig International, No Dig live exhibition years ago, before he had fully launched his company. So it's great to see how it's grown.
Good, thank you. Oh,
There you go. I'll make sure that we can hear through that.
okay. Should be on? Okay. Well, good afternoon, everyone. Is this on? You all hear it okay? Just to introduce myself, my name is Simon Drain. I'm the MD of Kobus Services. We're the manufacturers of the Kobus pipe puller. And yes, that is my real name. Okay, so I couldn't really work in any other industry, could I? Well, as part of the water industry's targets for leakage reduction, I want to pose a question really, which is it time to rethink service pipe repair? Everyone in the water industry, and we're all in the water industry in one way or another, we're all partners, we all want to try to reduce leakage. Even if you're not in the water industry, we're all consumers. So it's in our interest to reduce leakage. But really, are we actually combining the short-term, mid-term and long-term goals responsibly in this effort? If we look at short-term as being today, tomorrow, next week, next month, there are various methods that are used to repair pipes, detect leaks and repair them. But what about the mid and long term? If we took the mid-term as being, let's say 2025, the end of AMP7, and the long term being 2050, seems like a long way away, but that's one of the long-term goals that we know from Ofwat. The Ofwat targets, I'm sure they are etched in a number of your, across a number of your foreheads. You'd know them off by heart even now. Leakage reduction of 15% by 2025 and by 50% by 2050. So that's the mid and the long-term goals. Now I want to ask a question, and I'd like you to participate in this with a show of hands. Who here actually believes that the industry can achieve 15% reduction by 2025? A show of hands.
Can or will?
Yes.
Will. Can. What about will? Okay. Who thinks we wouldn't, the industry won't achieve those targets? So the rest of you just don't know. So there's not many in the room here that actually are saying we will achieve, as an industry, we will achieve those targets. And I assume you're basically thinking, well, we can't achieve them because of the way we do it now, or we can't achieve them because the technology that we've got in front of us that's visible to us isn't going to be enough. So we really need to rethink what we're doing. So I don't know how clear that picture is to you on the right-hand side, but I want you to take a look at that. This is a service pipe that's been removed from the ground. We use trenchless pipe pulling with the pipe puller to take this pipe out of the ground. It was 15 metres long. It's got a bit crunched up in the process of removing it. But how many connections can you see on that pipe? And I'll leave that with you to count. See how many you think you can find on that pipe while I just talk a little bit more. Current practice in the short term, today, tomorrow, next week, next month, probably the rest of this year, probably through most of the AMP period, is to find the leak and then fix the leak. And you'll have heard a number of talks today about finding leaks and the methods of finding leaks. There's countless methods, from even down to using sniffer dogs now that some of the UK water companies are starting to trial. So unless the pipe is lead, or unless the pipe is in particularly poor condition, generally the practice is to fix the leak and repair it. Find it and fix it. And generally that's done by just patching a piece into the pipe. And I think we all understand why the industry is doing that. It's quick, it's efficient, it's inexpensive, and it makes sure that we keep leakage at bay. All right? I mean, it keeps us on top of the leakage. Well, it's done so just about for the water companies in the last AMP period that will end next year. Just about, with a very low percentage of really leakage reduction. So a 15% leakage reduction is going to be a huge challenge for the industry if it continues doing the same thing. So going back to this, who wants to hazard a guess, or who's got good enough eyesight to tell me how many connectors there are in that pipe? Anyone think it was more than 5? Yeah, more than 5? More than 10? Yeah. There's actually 12 connectors on that pipe, a 15-metre length of pipe. I'm not going to tell you which water company it was that this pipe was in. but they might want to consider what their policy is on continually repairing a pipe, because that's got so many repairs on it, you wonder why they didn't replace it earlier. So why won't find and fix get us to meet our common goal of 2025 and 2050? Well, the very act of repairing the pipe is actually going to damage the pipe in the process and introduce more potential leak paths. So you might squeeze off the existing pipe to disconnect, to stop the water flow so that you can make the repair. That actual action of squeezing off the pipe is going to weaken the pipe in that area and be a potential source of a further leak. You've got to introduce some fittings to connect the new piece of patched pipe to the old pipe. Well, those fittings themselves are potential leak paths, whether through either a poor installation, movement in the ground later, or just maybe even a poor quality of fitting. The fact that the pipe is leaking suggests that maybe the pipe is reaching the end of its life. Not in every situation, but it could be that it's reaching the end of life. And one thing we know for sure is the likelihood is we'll be back to that pipe in the future, and we'll almost certainly be back to that pipe to repair it again before 2050. It's not really going to fix the problem. What I want to propose really is we move more towards find and replace rather than find and repair. There will be situations where repair is the appropriate solution, and the industry has got to try and keep up with the demand for fixing leaks. But by using something like the Kobus pipe puller, it's a trenchless technology, we can actually replace pipes far more efficiently than perhaps we could do in the past. And therefore it makes it more economical to think about replacing the pipe rather than continually repairing it. I'll give you walk you through a few case studies, a few examples of where the pipe puller has been used, just to give you a few examples. This particular one, and again I apologise for maybe the photograph isn't too clear for people at the back, but here there's a leak. There's a lot of surface water here, shows that there's a leak on a side pathway to a property. The leak is actually underneath a concrete path, and the pipe is buried somewhere underneath a 2-foot retaining wall, double-skinned as well. It's going to be very difficult to even find the leak, never mind trying to do a patch repair on it. If you wanted to mole a new service in, so actually to try to replace the pipe instead of repair it, you've got further problems. You've got other utilities under this pathway. The boundary box up here, the stop tap up here is about 4 feet higher up than the pathway. And obviously if you're moling, you don't want to be moling towards the house. So we use the Kobus pipe puller. Trenchless technology, we replace the whole pipe. So what is pipe pulling? Well, it's a very, very simple concept. If you think about the pipe puller is a winch. It's a hydraulic winch. We don't like talking about it saying that it's just a winch, because we like to think of it as a highly engineered piece of equipment. But it is a hydraulic winch. The technique involves effectively inserting a pulling cable through the old pipe. To one end of that pulling cable, we connect the PE pipe. To the other end, we connect the pulling cable to the spool on the pipe puller. You need 2 small excavations to do this, one at each end of the pipe, and the excavations can be as small as 400-500 millimetres square. So very small excavations. And really you're winching the pipe out of the ground. As you pull the old pipe out of the ground, the new pipe is pulled in behind it. So you're using the borehole created by the removing of the old pipe to pull the new pipe into place. Very simple technique, but very effective. Where can it be used? Well, we've talked a lot about service pipes, communication pipes, and the supply pipe. Stuart was talking earlier about the problems of leakage on the supply pipe on the customer's side. So this can be used on communication and supply pipes. It can be used on lead, it can be used on copper, it can be used on PE, black poly, it can be used on steel, galvanized steel. Typical sizes, 1/2 inch, 12 millimetre, up to 1.25 inches. So typical service pipe sizes. It will replace up to 25 metres of pipe in one pull, depending on ground conditions, but typically the lengths are anything from 6 to 15 metres in length. It'll tow in a new pipe, PE pipe, 20 millimetres, 25 or 32 millimetres, and the new pipe can be smaller or larger than the old pipe that you're removing. It works in most ground conditions, it can work on inclines, it can work underneath tree roots, and it minimises the risk of utility strikes. So if you've got other services around, because you're actually just replacing what's already in the ground, you minimise the risk of utility strikes. The Kobus pipe puller has been around a little while. It's been around a few years. We've replaced over 5,000 pipes in various places across the world, with over a 90% success rate on average. So going back to our case study, this patched up pipe, and we can see there's a repair in here, and there's another one, you probably can't see it there, and that was replaced in about 90 minutes with a new PE pipe, 15 metres of length. So you're maximising the asset, you're replacing that asset with a new pipe to meet this common goal of trying to get to 50% reduction by 2050. Less risk of utility strikes, less disruption to the homeowner. You're not digging up the entire side path to find the leak and repair it. And we're removing the decommissioned pipe. The old pipe is removed from the ground. It's not leaving the new pipe, the old pipe in the ground, which will act as environmental waste and cause problems when you come along later to do any CAT scans, CAT and Jenny scans. It's not going to show up on any of those. And it's cost effective in the long term. Another example, and I'll run through a couple of these very quickly. Here we've got a nice block paved driveway, not very old, but there's a leak underneath it. What we actually did was excavated, very small excavation, this is about 350 millimetres square, just inside the garage. The pipe puller was out in the pathway in the road by the boundary box, 16 metres in length, 1/2 inch lead pipe, and that was replaced in less than an hour, pulling the pipe out, rather than digging up the drive. Now, a block paved driveway is not too difficult to reinstate and get a nice finish, matching with the existing driveway. But that could have been a tarmac, it could have been a concrete imprinted driveway, which would have been very difficult and very disruptive to the homeowner's property, causing a lot of damage. This one is a typical road crossing. This is about an 8-metre road crossing. There's a gas main in the middle of the road, so difficult to mole. You can see the typical sort of size of excavation here to put the pipe puller in. Here was a previous repair. So they'd repaired the pipe once already, and in this case the water company decided not to put another 15 repairs on that pipe before they replaced it. They decided they'd replace it straight away, and this was replaced again using the pipe puller. So coming back to meeting our common goal, and I think Ian from Ofwat earlier was talking about the long term. You know, the industry needs to think longer term, and it's very hard sometimes to break away from the next day's job and just getting that leak fixed the next day. But if we're going to meet those targets, then we've got to think longer term. There are just a mass of initiatives to tackle leakage around the UK. You've heard a lot of them today. Innovation is known and seen to be critical to achieving AMP7 targets and to achieve the 50% reduction by 2050. And collaboration is going to be essential to bring those innovations to market. But innovations are rarely perfect first time, and the pipe puller is a great example of that. We've worked on developing this technique for several years, and we're still continuing to work on it. I'm going to a meeting with a water company tomorrow who's using our pipe puller quite regularly. They have more than one. They have a huge program starting in the AMP period next year, and they are wanting to work with us collaboratively to improve the effective and efficiency of it. And that's what we're really asking for, is to meet the long-term challenge. Seriously, we're going to have to collaborate more across the industry to bring these innovations to market. If an innovation is not known of now, then it's probably unlikely to achieve the AMP7 targets or give you any benefit in AMP7 by the time it comes to market. So even now, we need these innovations to be coming through even to meet the 2050 targets. And that's it. Thank you.
Thank you very much. So, again, I'm afraid we'll pass on questions to try and finish on time. And last but definitely not least, is Steve Lee, who I originally met through the Institute of Water. And
A long time ago, Joe. A long time ago.
Been looking at different ways of engineering surface pipes and associated parts with them, and he'll talk about some of his ideas.
Thank you, Joe. I can't hear this, so I presume everybody can hear at the back of the hall. Okay? Is it on as well? Are you all set? Okay, good. Good to see. So there we go. Well, it's nice to see so many people stayed behind. It must be the finale they've all been looking for, but there we go. Right, let's get stuck in. I think I've got unlimited time now, haven't I? Because I'm the last on the rod. Is that true? The longer we leave it, the better the traffic will dissipate. Oh, no. Okay. Right, it's a fairly quick précis presentation. I think that's a bit better to get us in the right position. Okay, what I'm looking to do is to just run through a few ideas about tomorrow rather than today. And as the title says there, are we still trying to resolve today's problems with yesterday's technology? We've heard an awful lot about it today, and I'd really like to see it happening. But at the moment, it's not really as such, and that's where the problems that we're going to have unless we actually move ahead. You're all familiar with these sort of scenarios. Typical excavations in somebody's footpath, underneath the front door, leaking pipe there, leaking boundary box, and picking up on what Stuart was saying earlier, that could be going for literally weeks. That was fairly near where I used to live, and it was going literally for weeks, and you can see all the street litter that's gathering in the water. It was angling in water, and they'd actually marked that it was leaking, which I'm sure was a great idea at the time. And other situations in other parts of the UK, when a leak has been repaired, a boundary box has been remediated, what you've got is clutter like that in the middle of the public footpath, trip hazard, etc., etc. This image came from Affinity Water. There's nobody here from Affinity, but we can talk about it. But clearly, they have an issue with waste plastic. As you can see there, and the sources from the WRC tell us that to remediate a boundary box, to dig it out and replace it, can cost anything between 250 and over 1,200 quid. Sheffield University a few years ago, and I think Joe was instrumental in putting it together, which was that Sheffield University came up with a very reasonable conclusion that a leak on a water service pipe is a potential source of contamination. You hope that the pressure in the main is going to be positive, but if it isn't, it's going to be drawing all sorts of refuse into it. And as a point making it at the bottom there, any work as such is from operational expenditure. So therefore, it comes out for the bottom line of the water company, all their profits literally going down the drain. Why? It's a long-held statement of mine that the difference between the gas industry and the water industry is that if gas leaks, it's a danger to life, and if water leaks, you get your feet wet. And I think that's manifested itself talking to various people during the course of the conference. The image here, I'm not sure if you'll see it from the back, that's by the by. Sorry about that, guys. You've got a gas pipe through here, very nice, tight electrofuse joint on there, and the pipe coming off at right angles, nice and neatly. And on the bottom here, you've got a water main. Okay, it's the bottom of the heap, literally, as you come into the utilities and the footpath. But the pipe comes up, you won't see it from this angle, but that came up at roughly 45 degrees. There was a joint there. There was a spare piece of pipe left in the bottom of the trench, so if you're trying to find out if and when this leaks, and you certainly will, there's a waste pipe there, and there's another one here, and then that goes into the property as it went forward. If that ever leaks, trying to find it and identify it is going to be extremely difficult. So the bottom line is, why can gas get it right and not water? Now, as a total aside from these things, I do happen to know that the water regulations people and the Home Builders Federation are actually getting very close together to actually put together effectively a passport to work. So hopefully that will come sooner rather than later. A couple of images kindly provided by Jo. She knows about these things. Effectively, what happens on a building site? Water was probably laid nice and neatly. Is it still working? Yeah. Okay, sorry. And effectively, it's a barrier pipe. It's been bent. It's been left. All sorts of things. So in terms of reliability, I think it's you can say that's pretty low. This one here has been crushed, and on the bottom here, the end of the pipe was been sealed in inverted commas with a piece of plastic bag. It's probably actually a gas tape on the top of it to stop any detriment or detritus getting into that pipe itself. So it's not exactly conducive to good water services. Conversely, you might like this one. On the building site, hole in the actual image itself, there's 3 or 4 boundary boxes. It was provided to me by a very good contact I have at United Utilities. Needs subtitled it Trenchfoot. We actually delivered it slightly differently to identify, would you actually want your cash register at the bottom of a muddy hole? Or we were mentioning earlier in terms of street furniture. This was, again, up in Greater Manchester. The lid of the boundary box had come off. It wasn't in the most salubrious of areas. And you won't see it from the back, but there's a tin can in there. There's an apple core, and it could, in the area it was in, it could also have had a syringe in it. In many ways, it could also, or certainly would be, a trip hazard. And the anecdote I have as far as that's concerned, from a water company who should remain nameless, but they're out of court payment to a lady who fell, broke both her arms. It was over £40,000. So any street furniture becomes a liability as you move forward. If you put the underground meter box, meter chamber in a front garden, or under the milk bottle as it's been called, this is often the scenario you're going to get. You certainly won't see it in that picture. Certainly, well, I can hardly see it from here, and I'm at the front of the room. There's a box buried in all the mud within here. When you take the lid off, or another property adjacent to it, it would now be covered by all the vegetable matter. And when you open it, highly likely you get something like that. Water in the bottom of the pit. Now, you don't know whether it's come from a seal over the lid or under the lid, which is let water by, whether it's groundwater, which is permeated in from underground, or whether it's a leak on the meter. So the poor homeowner needs to get in there to identify it, and indeed the water companies themselves need to bail it out before they can actually read the meter itself, and that's assuming they've got some form of, or they're still saying, with eyeball reading old technology rather than smarter technology, which we'll come on to in a moment or two. A few frightening thoughts for you. There are probably going to be something in the region of 250,000 new connections made per annum. So every time one goes in, that potential risk is going to go forward. United Utilities and the Home Builders Federation together came up with a report that more than 50% of new connections need attention within between 2 and 5 years. As I mentioned earlier, every time you dig a hole, replace a boundary box, it's going to cost anything between 250 Whereas I said £1,000 there, but it's actually something there at £1,250. And if you rationalise that out, it comes to over £300 million a year wasted cash. And that comes off the bottom line of the water company, full stop. So why do water companies continue to design out or design in problems which are going to give them major issues? And the fact at the bottom there isn't a single boundary box system or indeed the manifold that has protection against backflow to fluid category 2. Don't just take my word for that. Go and have a look on the Water Regs Advisory Services approvals list. Okay, I suppose this one sums up the previous slides. Why does the industry continue with dead-end thinking? Up to PR19, it's been mentioned today, we're looking to lose up to 20% of treated water. Okay, theoretically that's going to go down a little bit, but I think everybody's sceptical that it can't be done. When you work it out, that's over, what's that? 9,330 tonnes of carbon, or 1.8 million pounds per day. Why? When we've got systems that can actually remedy these problems now. And why do we continue with practices which are known to fail? Looking at new practices, we've been involved with United Utilities and a pilot they've been carrying out up at Sandbach up in Cheshire, looking at surface-mounted meter boxes, even smarter water meter management systems. And this is the output from a pilot, the surface-mounted meter box down here in the bottom left-hand corner. It's got a 5G transmitter based on it, and they're using Vodafone technology at the same time. It's very, very early days, very much immediately off the presses. And they're picking up a signal 3 kilometres away, that's 2 miles away from the site. So this is where smarter technology can actually start to move ahead. I'll come on to United Utilities policies in a moment or two. Otherwise, you're going to get this. Gentleman in question tried to read his meter in the middle of the highway. I think in this case it was slightly staged, but the guy in the van came along and says, "Oh, you're all right, mate. Have you fallen over? Are you damaged yourself?" And the guy said, "No, I'm just trying to read my water meter." And they thought, well, this is absolutely ridiculous. Why do we need to do this in the highway? That image actually came out of the Worthing Gazette, bless it, little cotton socks. So effectively, it just sums it up. If you or I need to go down there, my water meter's about, 50 metres away. It's one of 4 or 5, and I've got to try and remember which one it is, and I don't like doing it. I would like my water meter, and I do have a water meter, I hasten to add, to be on the side of the house, or a signal I can read on my mobile phone on a regular basis, which is really the object of our business case as we go forward. To sum it up, where do we like the future to go? Universal smart meters, yeah, they are being talked about. Anglian Water have announced that they're going to go smart over the next 2.5 PR periods. And I'm not sure if you would have seen it on your news wires during the day, but because of the purdah caused by the general election, Ofwat have announced there's going to be a deferment until well after the election before they make any announcements of who's doing what, where, when and how next year. So there's one for your notebooks. What we'd like to see is the home hub, whether that be your Hive, your Alexa, your mobile phone, or whatever it is, as being the hub. So anybody can actually read or see what's happening through their water supplies at any given time during the day or night. I know it's been talked about 1 or maybe 2 transmissions per day, and I'll put my hand up. Yes, we've just patented a product which hopefully would enable water services to take readings off a meter 24 hours a day, 7 days a week. But that's a little bit into the future yet. We'd like to see, sorry, go back one. We'd like to see online billing and accessibility. Let's make the most of the internet as we go forward. That's got to be better for the efficiency of the assets as we're going forward again. You guys have been talking about intelligent pipe systems. Yeah, that's got to be on the wish list. Smarter water meter networking. Yeah, if you can identify what's happening at any given time at any different location, then theoretically you could be able to process the amount of water out of the ground, put it into the pipes, and then deliver precisely what's wanted at any given time. Now, that's got to be a part of the wish list. Now, I know I say working together. We're manufacturers. We've tried to bring or get ideas and bring them to the industry. To try to talk to the water industry is hard work from time to time, as I'm sure we're all aware of. I'm also conscious of people like the Home Builders Federation, I've mentioned it a couple of times in my presentation, are trying extremely hard to work with everybody. They see it as a cost-effective solution to be able to deliver products at the right time in the right place, and it adds value to what they're trying to do. So everybody's literally trying to work in the same vein. I haven't mentioned it yet, but I suppose this is as good a time as any to. What we do, Groundbreaker, it's a surface-mounted water meter enclosure. It's fully RAS approved. Well, it's compatible with the sort of output you would find for both gas and electricity. I've already mentioned that the range from the surface-mounted meter can be infinitely better than that which is underground. If it's underground, you're lucky to get it as much as 2 meters in some cases. And we'd like to think we can interface with the other utilities in the future home. A couple of instances of it being installed, tucked away by the front door, parallel to the electric box. This one's using the pier, supporting the porch. Believe it or not, that one's actually on a park home, mobile home. And the one in the bottom left-hand corner I'll come to in a moment or two, because there's a bit better picture than that one. But essentially what we'd like to think is accessible. You don't have to grovel around in the highway. All the customer's got to do, even if they want to do an eyeball read, is flop the door down, read the meter, put it back again in, and job done. There's no liability in terms of street furniture, which is what I'm about to come on to with that liability. Mentioned cost early on. Every time you put a joint on a water pipe, it can be the same as at least 20 metres of pipe itself, so why bother doing that? I agree entirely with Kobus. Replace the whole of the service pipe. It's going to be a better way for the future and all the way. There are Home Server already doing something similar like that, and if you're not talking to them, perhaps you ought to be. That's another matter. Everybody's got to be trying to work together, as I've said before. It cuts out waste, it cuts out double handling, and moving to the better home, shall we say. Aesthetics, we usually get the comment from developers, well, we don't want another car bunk on the front elevation of our properties. Shouldn't be a problem. People like United Utilities have able to allow our Groundbreaker unit to go into any aspect of the dwelling, front, rear, side elevation, as the case may be, because they can see the business benefit it delivers. And we're looking to work with them to provide good and better working practices as we move forward. Reasons behind it. Stuart, you mentioned Portsmouth Water. I'm not sure if you've been contributing to, wherever you are, to the figures there, but these came out a little while ago. But effectively, they're the reported leakage figures from the various water companies over a period of time. And I was sent this, and the only one was significantly reducing leakage year on year was actually Portsmouth. Now, Portsmouth have actually been specifying our surface-mounted boxes for the last 15 years. So effectively, they've probably got somewhere around about 50,000 units installed over that period of time. They've still got a quantity of the old boundary boxes, street furnitures and liabilities. But I think what you can safely say is that that's been plateaued. And as they're moving forward, they're now looking at surface-mounted boxes, such as ours. What do they do and how do they do it? Instead of putting in the service pipe, as you saw from those first images, they asked the developer to lay a duct from underneath the unit, and so the Groundbreaker unit here, out the way to the main, point over the main, and inside that duct they want to pull a pulling wire. Their guys, when they come along, whether or not they're their own people or they're contractors, they pull the service pipe up and through in a single unjointed length from the main through to the point of delivery. They're still not accepting the fact that they take responsibility for that which is under the private property, but they will accept responsibility for the maintenance of the apparatus. Subtle difference, but effectively it's quite an important one as far as who owns what, where, when and how. A developer, or back in the early days, questions the legalities of Portsmouth Water's policy, which is mandatory for surface-mounted boxes. and Ofwat came down very much in favour of the water company being able to define their own terms and conditions. That's fine. We accept that. There are other water companies who stay with boundary boxes, and if we go back to the slide before, you'll probably find they're the ones with their leakage figures, if not going down, but they're certainly flatlining or maybe even going up. So effectively, we'd like to think that we're contributing to the bigger picture. Good for time. You're still able to go home, surely. Coming down to the reviews, basically what we're suggesting is that design in or try to use modern methods to eliminate maintenance. Design out leakage. Now's the time to do it. If it continues going the way, we'll always have the problem, as I said on the first slide. Remove street furniture, and the next slide should illustrate that a little bit better. Modern methods can cut down the time it takes to make a connection. Cost is king, so why waste the resources? And basically, it's understanding, not just what we're doing. You know, we're manufacturers. We try to talk to the water companies. We try to listen to what they're wanting and then deliver it back to the water companies. In other words, working together to try to find a common practice. Maintenance is dead money, and look at the whole life cost. When it was there this morning, was talking about TOTEX has got to be the way forward. It must be. It's the only way we're going to make sure this works effectively. You know this was coming, so there we go. Just to fill in a little bit of a gap, we've been talking a lot to modular home fabricators. This is a site at Salford. The developer came along and his utilities. They use a little pedestal, shall we say, which are ultimately covered to provide a kiosk for your electric and your water meter in here. The water main was laid down the footpath with tees off into the individual units very early on. As you can see from the image on the right-hand side, very nice images coming forward. These are accessible for everybody so they can see what's happening with the water meters, whether it's smart or otherwise. No street furniture whatsoever. So effectively, it's a nice, tidy street scene with all the utilities all very happy and tucked away off the beaten track. Because this was a modular homes, these came in literally off the back of a lorry, dropped into place, and the build programme went very, very quickly indeed. And we're looking to work with more modular home fabricators as we go forward. Incentives and disincentives, again, it's part of the wrap-up process. Water industry say that water connection charges should only be reasonably incurred when making a connection. We do note, and I won't say who they are, that some water companies are suggesting that they should include some of the maintenance within their connection charge. We're challenging that, not directly and otherwise. But water companies are certainly incentivizing developers to stay with boundary boxes, holes in the ground. It become a liability. That is identified. I'm rather hoping that under the PR, the latest review, whenever that comes out, that will actually be reflected. As you can see, the Ofwat have already indicated that there is support for operational preferences, i.e. such as Portsmouth. TOTEX again. Basically, surface-mounted boxes, direct access is not always required. Perhaps once every 15 years to change the meter. We've got a few ideas on how we can stretch that out a bit. Surface meter boxes, such as ours, are effectively free to the water company. We sell directly through to the end user via merchants. And I'm not sure if it came out in any other part of the conversations, but Anglian Water published a piece together with Honeywell, their meter provider, that a significant number of the smart meters going in have problems with backflow, potentially up to 20%, I'm told. That's when 10 litres or more of water flows back through from the home into the property for whatever reason. So effectively, there are issues like that, and that may have an issue on leakage. I don't know that side of the business very well, but if you need any more information, I can provide that as part of the package. And that, ladies and gentlemen, is just about it. Just to sum up, we're looking to justify. I think we've provided the justification to need to improve practices. We're looking at ways to facilitate ways of achieving those objectives and to design in the whole life sustainability and to integrate the systems within to house design as we move forward. And is that all right?
That's okay.
Okay, thank you.
Very much. I need the clip?
Yeah, I think.
I'd just like to. Oh. Hopefully that's. Definitely. Can you hear me? Yeah. Good. I'd just like to thank everyone who has stayed, which is the majority of people. And I'd also like to thank all those speakers who are still here. I appreciate you taking the time and making the effort to come along for what I think has been a really interesting day. Leakage conferences can be sometimes same old, same old. What we tried today was maybe show some alternative ways of managing the whole issue from start to finish. So I hope it's given everyone something to think about. And safe journey home. If you don't, if you're not a member of UKSTT, please look at the website. Please think about joining. It's a brilliant organisation that really works hard to try and educate people on what opportunities are out there and contribute a huge amount to the environmental credit of the utility industry and its sustainability. So safe journey, and we hope we'll see you at future UKSTT events. Thank you. Have I said everything?